Okay, so quickly, I'm going to speak about COBRACOMP and special study we made around the new braiding pattern proposed by George Cahuzac. I'm a professor at ENSAIT, which is a French institute in north of France working on textiles. And my laboratory called Gentex. First, I would like to say when we take a graph, when you take a graph like that one, you have axes, number of axes of the material and interlacing in Y. You have all the classical products called monoaxial, biaxial, like NCF, or non-woven structure, which have no interlacing, and the orientation could be monoaxial, biaxial, or whatever. Then very currently you have weaving and techniques. We give some woven fabric and knitted fabric, and then you have the braiding here. The braid could be biaxial or triaxial. I'd like to add that braiding is a very old technology. In fact, I used to say that braiding is a second job in the humanity life. The first one, you know the first one already, twisting technology, and the aim is to structuring the textile, and the idea is to interlace any kind of products like a roving, ribbon, wire, or strand. And so it was a very popular dance in the main month. They used to put a pool in the center of the village and to dance around the pool, and this make a braid. And the first French braiding machine was made by Mr. Perrault in the middle of the 18th century. What is braiding? You've got a lovely braiding machine on the screen, which is a Herzog one, about 2 meter diameter. And then you have to make the wires dancing around on the center of the machine that way. As you can see, the blue and red points, which are bobbin. Okay, and this is moving using orange here. And then you get a biaxial braid like that one. And if you put some yarn in the center of the orange here, then you can get some free axial braid, like it's illustrated here in carbon one. Here. Okay, so very easy technology, isn't it? George Cahuzac, when he proposed the solution, just well, clever guy, he analyzed these structures. As you see, the bias yarn and the axial yarn, and as you can see here, we got in the thickness 3 yarns, but sometimes we can get some only 2 or only 1, and then that means that the global braid is not homogeneous on the surface. So he did propose this kind of architecture, so this particular pattern. And as you can see, everywhere you are looking in the thickness, you got 6 yarn. 1, 2, 3, 4, 5, 6, everywhere. So the objective of George Cahuzac was to make a special structure to get better homogeneity. So I say it's patented. And his objective was to make a high axial resistance for the composite. The top of the sample we made with the new braid architecture. And then we decided to make a geometrical modeling that using a TechGen. So we got several parameters in order to set the final geometry. So this is a model, only a model. Why do we do that? in order to be able to put it into finite element software and to be able to compute and get some mechanical properties to predict mechanical properties. So this is the basic diagram, and then we got this 3D representation with easy geometry, yarn geometry. So it's nearly flat yarn. And so you can see the 0 degree yarn in blue, light blue, the plus 45 degree yarn in green and red, and blue and yellow, and crossing, interlocking into the thickness. Then we take this the sample we made and we put some resin on it, and then we are able to compare the geometrical model with reality. As you can see, if we compare, you can find the axial yarn in the middle, the axial yarn up and down, and then you have the crossing, the bias yarn in blue, red, green, and yellow. It's helped us, this kind of works help us to improve our model. And then we're going to put in Abacus software as soon as possible. In order to predict the mechanical property of such a structure, we decide first to use the classical laminate theory. And then first of all, we make a test of compaction. So here you've got the pressure, and here you've got the thickness. So you see, of course, when the pressure is high, light thickness is the thickness. And the same point, we study the pressure according to volume fraction. And as you can see, with quite high pressure, we get a volume fraction of about 45%. Using this kind of graph, then we can apply classical laminate theory. So we define the yarn used, the resin, and then using the classical the CLT theory, then we are able to predict a mechanical property of the braid. So here you got the Young modulus on the 0 direction, the Young modulus in the transverse direction, and the column modulus also. So depending of your process, composite process, then you are able to predict the mechanical property before to make the sample, according to this quite well-known and in basic theory. You have to be improved using finite element. So we saw already why we make this special pattern, braiding pattern, and the mechanical property we can expect. Then we have to make the machine. So we decide to make an axial braider. So this is the braid we can get. So we need two paths, two cylinders of braiding, and we have to move the yarn around the blue points, which are filled with yarn also. In the middle of the circle, we can add some purple yarn, two yarn, in fact, every time. And then we're going to turn the on gear, because it is gear assembly, so in what direction opposite to the next one. And then we can design the path for the red one, the path for the blue one, the path for the green one, and the path for the yellow one. And according to this cinematic, then we can get the original pattern designed by George Cusack. So first of all, we prove the possibility to make such a cinematic by 3D printing prototype, and this is the video. So, as you can follow with the zoom, this video just proves the capability of such a machine to ensure the good cinematic of the bobbin. Then we did work on the upscaling of this machine. So this is the CAD of the machine in the front, and you can find also the braiding ring here and here. So if you predict that direction, then the yarn will follow this way. And if you predict this direction, then yarn going to follow this kind of path. So this is the 3D representation, 3D design of this kind of machine. And here is the real machine. So only one carriers, foot of carriers is set on the machine here. And here is the dimension. And this is another video of this machine.